So this week we're going to look at graphing rational equations, rational functions. The hard part about graphing rational functions is unlike quadratics, where they typically all have the same shape, so you know that is what a quadratic can look like. It could also look like this. It might be nice and skinny, okay, or it can be a bit wider. We've seen rational or radical functions rather that all take the same shape, something like that. It can be shifted over like that. But regardless, all the families of functions we've looked at, all their child functions, all look relatively the same, and that's not necessarily going to be the case with rational functions. So if you take a look here, we have four different rational functions, and the equations, they all look relatively the same, okay? But their graphs do look different, and there you can see that it comes in this case, two different pieces, okay? If we look here, here are some rational functions that come in three pieces. Now, this week, I'm not really concerned with you guys actually graphing them, okay? You guys can always set up an XY table and plug, say, -1 in and get a Y value. Then you plug 0 in and get a Y value. You plug 1, so on and so forth. You can also use a graphing calculator. If you use a graphing calculator, you go to your Y equals, you plug in a rational equation. So in this case, I'm plugging in 3 over x plus 2. Notice I put my denominator in parentheses. And then if you want to look at what the graph looks like, it would look something like that. If you need specific values to plug in or to graph, to plot, you can go to your table and get some XY coordinate points. You see that at -2 it comes up with an error, which we'll talk about. And you see that in this particular function, as x gets larger and larger and larger, y gets smaller and smaller and smaller and goes to 0. That's, again, something else that we're going to talk about. I just show you these two functions a couple slides ago. Now, what I'm concerned about this week is you guys being able to identify, I'm highlighting in green, we call these vertical asymptotes. So you see we have 2 on the function on the left. Can't really tell, but there's one here, and there's one here. So those are vertical asymptotes. They're almost like imaginary lines that our functions sort of approach and get closer and closer to, but never actually touch. I'm also concerned that we can identify, and I'll do it in blue, these called horizontal asymptotes. Again, these are horizontal lines that our functions approach. Unlike vertical asymptotes, they can actually touch, as you can kind of see that this one on the right almost looks like it does touch. And then the third thing I want to be able to identify, which we'll look at the function on the right, are these holes. You can kind of see, oh, that actually might be a hole right there. Holes. So I want to be able to have you guys identify all three of those features if given an equation. And that's what the next couple of videos will walk you through.